Hello, everyone. This video will be going over our day one uh, during our Mastery Week review. I'm sorry I can't be there in person. I'm hoping to feel better by this Wednesday so that we can have our day two together in person and I can answer questions for you personally. But unfortunately, we're going to have to proceed just with this digital lesson for today. Okay? So, without any further ado, let's go and get started. So the main concept I want to go over is the concept of factoring. So this should be a word that we're very familiar with, but I know that some of us still aren't 100% comfortable with it. So I want to make sure that we give you enough time and enough support so that you're able to take this skill and use it on your test. So for some of us, this will be review, or for all of us, this will be review, but it's going to be more necessary for some than for others. But it's an important concept, so it's worth going over. So the definition of factoring is to break an expression or part of an expression up using multiplication. So that's the keyword multiplication. We break something up using multiplication. So we could factor numbers. We could break up a number into its multiple multiplication parts, multiplication facts. That being 3 times 4, 2 and 6, 1 and 12. Or we also could factor quadratics are ax squared plus bx plus c. Or we might be able to do both in one. We might be able to factor out a number and a quadratic in the same kind of problem. So that's the definition of factoring. But the main association I want you to make is that when you think factoring, I want you to think of box method. So factoring should already make your box. It may be our large box like this, or it might be our smaller box like this. But when you think factoring, first thing you want to do is think box method. How do I use my box? So with that in mind, let's go ahead and take a look at our first type of factoring, that being taking out what's in common. So when we take something out that's in common, we are factoring, and that's when we use our smaller box method. The setup goes like this, where we take a look at what's in common in an expression, and we put on the outside of our box to the left. We put the expression that we start with inside of our box, and in we split it up by the different terms that it has. And then we say, hey, if we're taking something out, surely we have something that's left over, which is what's going to be on the top of your box. So factoring type 1, we are taking out what's in common, and we are stating what's left over, so that we're going to have some value that we took out, some value on the outside of our parentheses, and some value left inside of our parentheses. And this is the form that our answer is going to take when we factor this first type of way by taking out what's in common. We are given an example here. Pause the video, take a second, and see if we understand how to answer this question, to break up this question. Okay, so we're trying to factor out what's in common, and we're going to do that by looking at each of our terms. So my first term is 5x, my second term is negative 25. Should actually definitely include that negative in there. So I'm looking at these, I'm trying to see what they should have in common. And remember, we're talking about factoring, which means we're talking about multiplication. So we're trying to figure out what multiplication facts they share. So how does 5 and 25, what multiplication facts do they have in common? And after a little bit of thought, we should be able to come up with that they both are part of the 5 multiplication facts. So that means I could take a 5 out of this expression. So when that happens, I took what I have in common, I put on the outside to the left, and I write my actual expression inside. So 5x and negative 25. I'm just writing my expression, but I'm splitting up via terms. I'm splitting it up into its terms inside of my actual box. So I have two terms, I have two boxes. And then I need to figure out, okay, so if I do take out a 5, what's left over? So I ask myself, okay, 5 times what gives me 5x. And what I'm missing is that x. 5 times x gives me 5x. Similarly, I'm looking at 5 times what gives me negative 25. And that is going to be negative 5. So that when I factor this out, I factor out the 5, and what's left over is x minus 5. And this is my final answer. Okay, so that's one example. Let's see and take a look at another type of example. So the first example given only had two terms. This one has three terms, but the way we solve this, the way we approach this, is the same. So once again, I'm trying to see, do these terms have anything in common? So I'm looking at 5x, 10x, and negative 25. And once again, we notice that they are part of the 5's fact family, and all of them share a 5 in common in their multiplication fact. So 5 goes into 5, 5 goes into 10, 5 goes into negative 25. So I'm going to take a 5 out on my left-hand side of my box. And I'm going to write 5x, 10x, and negative 25. Okay? So from there, I could actually take out a 5 from each of these. So 5 times what gives me 5x? That's going to give me a missing x. 5 times what gives me 10x? That's going to give me 2x. 5 times what gives me negative 25? That's, of course, going to be negative 5. So this is all going to equal x plus 2x minus 5. And of course, I can combine my like terms. That's going to be 3x minus 5 is my final factor. 4. Okay? And our third example, uh, go ahead and see if you can do this one on your own. Pause, give this a try, and we'll see how we do. Okay, so it's first things first. I'm just trying to factor out what's in common. And looking at my 12x to the third, 6x, and negative 18x, I notice that they're all part of my 6 facts family. 6 goes into 12, goes into 6, goes into negative 18. But you'll notice that each of these terms has an x value as well. So that means that since they have an x in common, I can also take an x out. I put 6x on the outside, that's what they all have in common, and I'm going to put 12x to the third, 6x, and negative 18x on the inside. And then I ask myself, okay, 6x times what gives me 12x to the third? That value is going to be 2x squared. And now I'm going to look at my second term. 6x times what gives me 6x squared? That's going to be x. And 6x times negative 3 gives me negative 18x. So this is all going to equal to 6x times 2x squared plus x minus 3. And as far as factoring my type 1 way, I am done. Could I factor this quadratic? Yes, but for right now, we're just focusing on how to factor using our type 1 method, that being taking out what's in common. As far as taking out what's in common, I have accomplished that. 2x squared, x, and negative 3 no longer share anything in common. Do my first two still have x's? Yes. But when we're factoring something out, you want to make sure that they all have something in common and not just part of it. So right now, I am done factoring using my type 1 method. So with that in mind, I will let you try these next couple problems on your own. Answer key will be posted onto your Google Classroom or somewhere. I'll make it available to you either today or I'll be giving the answer keys to uh, whomever is looking after you guys right now. So keep an eye out for that. Try these out and then check to see if your answers are correct. All right, I hope you're successful in factoring all of these out using our type 1 method. So when saying that we have a type 1 implies that we have a type 2. And this is going to be our, what I kind of refer to as our standard factoring method in this class. So generally speaking, when we factor, we're using our box method, our large box method, because we are factoring quadratics more often than not. So quadratics are any equation that has the form ax squared plus bx plus c. You've seen plenty of those. Hopefully, we're familiar with them already. But the way that we factor these is by making our large box, and our first term goes in our first box. Our last term goes in our last box. And our middle term gets broken up and gets put into our middle boxes here. Putting our first and last values inside our box hopefully are pretty straightforward. You just whatever my ax squared value is, I put in my first box. Whatever my last value is, my c value, I put in my last box. But it gets a little bit more complicated once you're trying to figure out what goes in my other two boxes. And what we do is we either, well, what we should be doing is using this method here, where we have our a and c values. So this is going to be our ax squared times c goes in the top part of our uh, cross section, or diamond it was called, and we put our middle term on the bottom. And the whole idea is what multiplies to be our AC term and also adds to be our middle term. So I'm trying to figure that out. Now, many times, many times, you are not going to have an A value. Your x squared will not have anything in front of it. So when that happens, all you're really doing is looking at your C value and trying to break that up. But when you do have that A value, you must make sure that you multiply A and C, your first and last term, and use that value in order to figure out what needs to be multiplied to. That adds up to be B, your middle term. Okay? So let's go ahead and get to our first example. Uh, Before each example, I'm going to go ahead and ask you to pause and to try each of these out on your own. So pause this video, take a second, see if we are able to factor the quadratic x squared minus x minus 90 so that we get our two parentheses values outside of that. Okay? Try that out and then come back to the video when you think you have an answer, or else get stuck. Okay, let's see how you did. So, of course, I'm going to go ahead and make my box. I'm going to put in my first term and my last term. That being x squared is my first box. My last term, negative 90, goes in my last box. And what I'm trying to figure out is how does negative 90 break up? What times what gives me negative 90? That will also add up to be negative 1. I'm choosing negative 1 because that's my middle value. There's an invisible implied 1 here. So I'm trying to figure out how do I get this to be negative 1, because that is the value that's in my middle term. So the reason I'm using 90 rather than any other number is because x squared times 90 gives me 90x squared. So there's no change in the numbers that I'm working with when I put it inside my generic diamond. And of course, what I'm still aiming for is negative 1x. So if this helps you to visualize and organize your work, that's totally cool. But until we have an A value here, this is not required. If it's useful, more power to you. But we also have our standard factoring method, just breaking up our negative 90 to see what we could break this up into in order to get our negative 1. And through some experimentation, let's just have some things that multiply to be negative 90. We have uh, 90 and 1, we have 30 and 3, we have 9 and 10, and you could keep going on, but these numbers will be enough, and you'll see why in a moment. So 90 and 1, adding or subtracting those are not going to give me a negative 1. Same thing with 30 and 3. However, I noticed that 9 and 10, those are 1 apart. So if I'm clever, I can make that be a negative 1. Now, I want more negatives, so I'm going to make my 10 negative, and this is, of course, 9 minus 10 will give me negative 1. So I found my combination that works. Now, once I find that combination that works, I put it inside of my box. So that's going to be 9x and 10x. I got x and x, negative 10 and 9, and this is going to give me my factored answer, x plus 9, x minus 10. Whenever you factor a quadratic, you will know when you're done when you have your two parentheses filled out. It should be usually x plus or minus some number, x plus minus some number. Your answer must be in this form. If you stop here, even though I can see what you're doing, that's not enough. You must write it back in your equation form using your two parentheses. But that's the long and short of it. That's how we do it. So once again, I'll give you an opportunity to pause, try this one. There's a trick to this one. Let's see if we could remember what that is. So you may be thinking to yourself, hey, I can't factor this. There's no middle term. Usually I have my ax squared plus bx plus c. There's no middle term. I have no b term. I have my ax squared. I have my c, but I have no bx. So what's going on? What do I do with that? So you're correct that there's no b term here. However, just because it's not there doesn't mean we don't know what value it has. As a matter of fact, because there's nothing there, we know what value that's going to be. So whenever you have a binomial, whenever you just have two terms instead of three, what I want you to test, what I want you to try is to put a middle term of 0. Test 0 as your middle term. So x squared plus 0x minus 9. Try your box method and see if you're able to make that work. So once again, I do first and last, and that's going to give me what gives me 9. So I have a negative 9, I get 9 and 1, I get 3 and 3, and right away I see 3 and 3. Hey, I could cancel those to make 0. I just need one of them to be a negative, and since I have a negative 9, that means if I make one of my 3's negative, then these will cancel. Negative 3 plus 3 will give me 0, which is my desired middle term, which means that I found a pair of numbers that works. So I'm going to put negative 3x and 3x. This is going to turn to x and 3, x and negative 3, which is all going to equal x minus 3, x plus 3. Okay? And if you were using your generic diamond method, this would have been 9x squared and 0x. And of course, we have our 3x and negative 3x for you to input your values in your triangle method, in your diamond method. Okay? So, those are the quote unquote uh, uses of factoring that we're going to go over for the test. Now, again, the test is not going to have a factoring question. That's just going to be straight factoring. Factoring is going to be a tool that we are going to use in order to answer questions of a higher level. So, go over this part of the video if you need to, but the next thing we're going to tackle is what type of questions we're going to encounter on our final that are going to use factoring. So the two types of questions that are going to need to use factoring in is from our Unit 2. You will use factoring when trying to graph a parabola. So this slide should be familiar from your study packet that I gave you guys to look at over the break. So hopefully we looked at that. But where factoring comes into place is in obtaining our factored form. So standard form is our ax squared plus bx plus c. And our factored form is after factoring, we have our expression written out as the product of two parentheses. And of course, our vertex form we get by completing the square. The only thing you need to worry about for this section is going from a standard to factored form. I will give you vertex form, so you will still need to remember how to pull out information from vertex form, that being h and k are our vertex. So my vertex would be h comma k for any given vertex form. But as far as factoring or factored form, you must know how to get from standard to factored form via factoring. Okay? That's all we're looking to use factoring for in Unit 2. And Unit 3, you will see factoring in the type of question where you need to simplify rational expressions. So the steps for simplifying a rational expression, uh, to answer your question, these what I mean by factoring a rational expression is going to be sum ax squared plus bx plus c all over ax squared plus bx plus c. It's going to be two quadratics that are being divided by each other. They're largely not going to be the same, but so you can't just cancel them right away. You must factor them in order to find out their parts so that you could then cancel uh, your new parentheses that you got. Remember, you cannot cancel parts of a quadratic, so I can't just say cancel my x squares, cancel my c's. You must only cancel a whole with another whole. Can't cancel part of something just because they match. Okay? So that's what that kind of question looks like. And of course, the way we use factoring is because, like I said, I'm not going to give you any quadratics or rational expressions that could be canceled right away. So you must factor first in order to simplify your answer a bit, and then cancel the results. So the first things that you do is to KCF, keep change flip. You only KCF if it's a division problem. So you keep change flip your fractions. Look at your notes, and we also have an example of what we mean by keep change flip here. And then step 2 is where all your factoring work comes from. So you're going to factor by taking out what's in common first in your type 1 method, and then you're going to factor quadratics using your type 2 method. And then from there, you just cancel. So factoring is a very integral part of simplifying rational expressions. If you are not able to factor properly, then you are not going to be able to solve and answer these kind of problems. Factoring is a key component of our Unit 3, so you must make sure that your factoring skills are on point for these types of questions. Okay? With that in mind, we just have your worksheet to go over. So let's go ahead and get straight into that. All right, I've given you 10 practice problems in total. And numbers 1 through 7, it asks factor the quadratic completely by first factoring what each term has in common, our small box method, then factoring the quadratic using our large box method. You will not need to do both for most problems, but you must check to see if you're able to do both for each question. So I'm not going to do each one with you. I want you to go ahead and try these on your own. That's just for number 1 through 7. Number 8 and 9 and 10, these are example problems that we'll see on your final. So pages or numbers 1 through 7 are just factoring practice. If you feel confident about your factoring skills, you can skip straight to number 8, 9, and 10. But please make sure to check your work, keep yourself organized. And with that in mind, like I said, I'm not going to go over each problem with you, but I will give you enough practice, hopefully, uh, show you enough examples for you to hopefully get a good grasp on how to solve these type of problems. So we've done most of these kinds of examples, uh, except I do want to highlight number 4. So number 4. This one, you'll notice that we do have a front term. I do have a 2 in front of my b squared here, as well as a n term of 21. So in this case, it's very important, very pivotal that you keep your work organized here. So before I even do my big box method, I say, hey, there's 2 in front of here. But hey, maybe I could take something out because they have in common. So you're going to look at 2, 17, and 21 and ask yourself, do they have anything in common? Can I just factor something out before going on to this box method? And the answer is, in this case, they do not have anything in common. So that's when you go to your big box method and go as far as you can. So I have 2b squared and 21. Now, since I have a term in front of my b squared, in front of my first term, that's when I use my generic generic rectangle, generic diamond method. And that means I'm going to take my first term, 2b squared, multiply it by 21, and I'm going to get 42b squared. And of course, I'm aiming for my middle term, 17b. So now I'm looking for numbers that multiply into 42. That will also give me 17. And through some process of elimination, I have to break down what gives me 42. So 42 and 1 give me 42. I know 21 and 2 give me 42. And 42 comes up in our multiplication facts only once, that being 6 and 7. So looking at this list so far, if I try any of these combinations, I'm still not getting my 17. So when that happens, you need to make sure that you break down even further. Make sure that you're covering all your bases. So I'm looking at my 6 value, and I know that 3 goes into 6. And if 3 goes into 6, that means 3 will also go into 42. So if you're ever stuck and you're not sure, hey, I don't know how to break up 42, look at your parts. How can I break up these parts? And whatever those parts break up into, they will also go into what you started with, in this case, 42. So 42 times what? Excuse me, 3 times what gives me 42? Well, through some division using your calculator, you figure out that the answer is 14. And this is our winning combination. Because 3 and 14 give me 17. So this is going to be 3x and 14x. Excuse me, not x. We're using b's for this case. That's going to be 3b and 14b. And when I factor this, I want to make sure that I align my numbers in such a way that I don't get any fractions. So that's why I'm going to put my 2b on top, because I want it to interact with my 14. I'm going to put my b on the side. So b times 3 gives me 3b. 2b times 7 gives me 14b. So my final answer is going to be 2b plus 3, and then b plus 7. And this is my final answer for number 4. Number 5 is very similar to what we did on number 4. So if you're ever stuck or confused on what to do, I would very much look to number 4 first. That being said, you'll notice that they also have something in common. So for this one, you are going to use both your small box method and your larger box method. So I will let you try that one on your own. If you have questions, I will be posting an answer key over this weekend so that you can study it. But I do want you to work on this. I do want you to struggle a little bit so that you're able to build your skills up, play around with it as much as you can, and see if we are able to get our final answer, our correct answer. Number 6 and 7, we just went over this in the notes, so I will leave these for you to do on your own. And with that being said, I think you have enough practice to try the rest of these on your own. In that same vein, I will go over the types of questions you'll see, but again, I want you to try these ones on your own. Okay? So I will try and give you as much setup as I can, and then I will go ahead and let you try these out. But number 8 reads, find the x-intercepts and the vertex of the following function, then graph the function. So, like I said, I will not be expecting you guys to complete the square. I will give you vertex form, but I need you to know, hey, How do I get my vertex from here? Ask your neighbor, look at your notes, try and remember, how do I get my vertex from my vertex form? So that's going to be step one. Secondly, your factored form, I need my two parentheses from factoring my main expression here. Once you get your factored form, what you need to do is set these parentheses equal to 0, which will then get you your x-intercepts. So when you solve for 0, you should get x equals some number, and those will be your x-intercepts. You're going to use those intercepts as well as your vertex to go ahead and graph the graph of the line of the function on your given graph here. Now, I just chose whatever random points, but I'm telling you that your final answer should have some graph uh, as part of your final answer. You're not just giving me the x-intercepts of the vertex, you're actually graphing those out. Looking at 9 and 10, these are both questions from Unit 3. And this is really just a big factoring question in disguise. It says factor and simplify the rational expression. What I need to do is factor your numerator, factor your denominator, and then cancel whatever you can. So you're factoring and then canceling. Make sure that you factor first, because as of right now, you cannot cancel anything. I can't just cancel my parts. I can't cancel x squared and x squared. I must factor first in order to get my two parentheses, so that then and only then I could cancel my parentheses here, my new parts. Okay? Looking here, it's the same thing. So you're going to factor 1, 2, 3, 4 times. You're going to factor 4 different quadratics. And then after that, like we did in number 9, you're going to go ahead and cancel whatever you can. The only other trick here is this division. When you're dividing two fractions, you must keep, change, and then flip. So you're going to keep your first fraction. You're going to change your division into multiplication. And as you do that, you're also going to flip this last fraction. Okay? Again, I don't want to give too much away because A, you've seen these types of problems before. I want you to activate your past memory and look at your notes and be able to work on this. And if you don't remember, then I want you to try and think about how to do these kind of problems, what I've given you so far, try and answer them. I know it might seem that we're struggling a little bit, but that is how we learn. So try these out on your own. If you don't understand, please ask questions. And don't fret, I'll be posting answer keys to this over the weekend. But I need us to try to do this on our own because that's how we learn, through struggling and trying to figure out things, figure out problems by looking at them, working at them, and just trying our best with them. Okay? That brings us to the end of what I had prepared for our lesson. So sorry I couldn't be there in person again today, but I'm trying to set you guys up for success. So do your best, ask questions, and I will see you guys later this week. Take care.